As you've learned before, a power is made up of a base and an exponent. In this case, the base is the 5, which is right here, and the exponent is the 3, and we would read this as 5 to the third, or 5 cubed. And what we're going to be doing in this video is multiplying powers with the same base. Right here we have c to the third times c to the fifth. The base in this one is c, and the base in this one is c, so they have the same base, so we can multiply them times each other and do something special. So first of all, let's look what c to the third is. C to the third is c multiplied by itself 3 times, and c to the fifth is c multiplied by itself 5 times. So it would look like this: c times c times c multiplied by c times c times c times c times c. So how many times do you see c multiplied here? 1, 2, 3, 4, 5, 6, 7, 8 times. So if you have c multiplied by itself 8 times, then you have c to the 8th power. Now, how could we do this so that it would be a little simpler? Because if you had c to the 150 times c to the 160, you wouldn't want to write out all those c's. So what shortcut could we have? Well, we started out with 3 c's and 5 c's, and we ended up with 8. 3 plus 5 just so happens to be 8, so all we have to do is add the exponents. So when you're multiplying powers with the same base, what you're supposed to do is take the exponents and add them together. So c to the 3 plus 5 would be equal to c to the 8. It's very important to remember that this only works whenever you have the same base. Okay? Let's try one more. This time we've got x to the 4th times x to the 6th times x to the 7th. Now you just learned that what you're supposed to do is add the exponents. So that would be x to the 4th plus 6 plus 7. 4 and 6 make 10, and 7 makes 17. So the answer would be x to the 17th. And finally, we've got d to the negative 2 times d to the third times d. So once again, we'll add the exponents. So that will be d to the negative 2 plus 3 plus 1. Very important to remember, if there's a variable that does not, or a number that does not have an exponent shown, it's understood to be a 1. Okay, so that would be negative 2 plus 3 plus 1. Negative 2 and 3 make 1, plus 1 makes 2, so our answer is d to the 2nd. So the important thing to learn from this is if you have powers that have the same base. In the first example it was c times c, in the second example it was x times x times x, and in the third example it was d's that were the same power. If it was mixed up in any way, you could not add the exponents. Now in these examples, what we're going to be doing is multiplying powers that have the same base, but they also have coefficients. Remember, the coefficient is the number that's in front of the variable. So in this case, the coefficient is 2, and in this case, the coefficient is a 3. The only difference between the previous example and this example is that you multiply the coefficient times the coefficient, and you multiply the power times the power. So that means we'll go 2 times 3, and we'll do c to the 2nd times c to the 6th. 2 times 3 gives you 6, and c to the 2nd times c to the 6th gives you c to the 2 plus 6, which is 6c to the 8th. All right, one more. This time we've got negative 5x to the 5th times 3y to the 6th times 2x to the 4th. What do you notice here? Well, in this one we've got an x, in this one we've got a y, and in this one we've got an x. So the only two that we can add the exponents when we multiply them is the first one and the third one, because they have the same base, an x. Okay, the y is different, so you cannot add the exponent of the y. As we did in the previous example, we multiply coefficients times coefficients and variables times variables. So this would be -5 times 3 times 2, which gives us -30, and it would be x to the 5th times x to the 4th, which would be x to the 5 plus 4, and we add those together and we get x to the 9th. And then the y to the 6th is as simplified as it can get. So we go, our answer would be -30, x to the 9th, y to the 6th, like so. And the last thing we'll look at is raising a power to a power. So here we've got x squared to the 3rd. Remember, the exponent tells you how many times to multiply the base by itself. And since the x squared is in parentheses, that makes it the base with an exponent of 3. But let's look back in just a moment. If we had x cubed, or x to the 3rd, that would mean to multiply x times x times x. So if you've got x squared to the 3rd, that means you're supposed to multiply x squared times itself 3 times. And now we're multiplying, just like we did in the examples so far in this lesson, we're multiplying powers that have the same base. And when you multiply powers that have the same base, you just add the exponents. So this would be x to the 2 plus 2 plus 2, which would be x to the 6th. Now, what can we learn from this one? Because if we had x to the 5th to the 100th power, you wouldn't want to write it out that many times. So what shortcut can we learn from this? Okay? There's a lesson to be learned, and there's a quick way to do it. How do we go from this 2 and this 3 to this 6? Because you can't add a 2 and a 3 and get 6. But what can you do? You can multiply 2 times 3 and get 6. Remember, multiplication is just a fast way of doing repeated addition. See, this is 2 plus 2 plus 2. How many 2's are there? 3. So we just go 3 times 2 and we get 6. So when you raise a power to a power, all you have to do is multiply the exponents. So that means that x squared to the 3rd will be x to the 2 times 3, which is x to the 6th. Okay, now let's apply it to this one. X to the 3rd, y to the -2 to the 4th power. So as you learned, what you're going to do when you raise a power to a power, you have to multiply the exponents. And that 4 that's on the outside of the base here tells you to multiply x to the 3rd times itself 4 times, and y to the -2 times itself 4 times. Because that 4 goes with each thing inside the parentheses. Okay? So that will be x to the 4 times 3 and y to the 4 times -2. See, 4 times 3, 4 times -2. And when we multiply that out, we'll get 4 times 3 is 12, and 4 times -2 is -8. But remember, we cannot leave it with a negative exponent. We want to have positive exponents. And what does a negative exponent tell you to do? A negative exponent tells you to move the power to the other side of the divisor line. In this case, the y to the negative 8 is in the numerator. So to make it positive, you'll move it to the denominator. So this will change from x to the 12th, y to the negative 8, to x to the 12th over y to the 8. Because when we move the y to the negative 8 to the denominator, it becomes positive.